Who does math on Saturday? I know, I'm kidding. I'll go into more detail with that later. So, all right. Thanks, Rob. Appreciate it. All right. So, back to this. These are my office hours. I encourage you, if you're going to get help, to come to me for help. Right? I mean, it's always best to go to the source, right? If you want help. But the labs are there. The book that we'll use is the same book that we've been using for a few years, McKenna Kirk, or the authors. You can use this for 0302 and 0303. Now, I need to talk to you about 0302, 303. I don't know if you all know this, but there are some huge changes that have been mandated by the state of Texas. The developmental math sequence used to be, what, 3 classes, or 4 classes? Used to be 0300, then 0301, 0302, 0303, and then you get to go in, college algebra or wherever it is you want to go. Those were the 4 levels. So you're here, right? So after this, you'll have to take 0303. Well, the state came in and said, no more with this. They created 3 new levels. Instead of 4, 3. All right? And so right now, you are on this track. If you succeed in 0302 this semester, then next semester you have to pass 0303. If you don't pass 0303 next semester, you automatically get kicked into this layout and you have to test in, and you may wind up testing into 310. So even if you don't pass this class, you might have to test in and wind up somewhere in here. In other words, this could slow you down. So I encourage you to, work hard to complete this out, because y'all are right at that transition from one program to a different one. Does that make sense? Any questions on that? All right. But we'll be using this book, and we'll be using this book to finish off 303 next semester. After that, these won't be offered anymore. Okay? No questions on the book? I expect you to have the book by next class. So I'm not going to assign any homework out of the book tonight, but next class I will. So you'll have to have it. Yes. Yeah, if you took 0301, it's the same book. Okay, the description of the course. Of course, you should have passed 0301 or placed into this class. If you did not pass 0301 and you're here, you shouldn't be. So be warned. Learning outcomes, the student learning outcomes here. I'm not going to read through those. Let's get to the grade. Okay, the way I do the grade, standard grading scale, I need to fix this. This is wrong. In developmental math, a C is 75 and up, not 70 to 79. It's 75 and up. Okay? So I'll change this. I'll let you know. I'll tell everyone I posted the updated syllabus, and then it'll be official. Here's how I determine the grade. Your lab is 5%, so that's the lab the gentleman was talking about. That's an open lab. You go there anytime you want on your free time within those hours, and you're supposed to log 800 minutes. They've bumped it up from 600. It's more. And that's 5% of your grade. Now, because it's a walk-in lab, you can wait and then do a bunch of hours at one time, but I would encourage you to not wait till the end, because that kind of defeats the whole purpose. You go in there the last week of school and you sleep in there for like 4 days. That's not the idea, okay? So I'll be getting reports on the lab every couple of weeks, and they'll send me a printout, and I'll know where everyone is on that. Now, here's my philosophy on the lab. If you're doing fine in the class, okay, you're passing all my quizzes, you're passing the test, and you're not doing the lab, I'm okay with that. That means that you understand it or you're getting help somewhere else, that's okay. But if you are not doing well in the class and you are not attending lab, that 5% is going to hurt you. Because if you're not doing it somewhere else and you're not succeeding in the class, then you need to be going to that lab. So it's just a way of getting you ready for the idea of a college level math class like college algebra, they don't require a lab. I mean, you're pretty much on your own. You leave the class, you're on your own. And at some point, you need to get to that too. So if you can do it without the lab, we're going to be okay. Does that make sense? All right. Quizzes. I would expect a quiz every day. All right. You could get it. I do quizzes. I've been known to give 2 quizzes in one day, one at the beginning, one at the end. The quizzes will range from you do a problem or a group problem. You know, everyone's working on the same thing. Open book, open note, open homework. It just depends. So always bring all your materials to class. Come prepared. If I give you a homework assignment, the next class, bring it. Okay? That way, if I say, hey, you can take this quiz and you can use your homework and you don't have it, well, that hurts you, right? But all those quizzes added up, and I would expect about 10 to 15 quizzes total. All those quizzes added up, I will drop the 2 lowest grades. That'll be 15% of your grade. Then you have 4 exams within this semester. Exams 1 through 4, 15% each, that's 60% of your grade, and then the final exam. So the final exam, again, for those of you who are first time in college, the last week of school is finals week. All you do is take finals. And instead of having the hour and 15 minutes, we have 2 hours, 45 minutes to take the final. So that's why that exam's worth more. And when we get to that final, we'll talk about what's on it. Right now, you know, I don't know. It's hard to say. Okay, course policies. Attendance. I will be passing around an attendance sheet every day. If I forget to pass this around and you remind me, I'll give you some sort of bonus, a 1-point bonus or something like that, because I do forget about this. But I need to get everyone's initials on this every day, so I have a record of who's here. Okay? So if you're sitting there and we're like 30 minutes into class and I haven't passed this around, if you say, hey, where's the attendance sheet, I'll mark you with a bonus, all right? That way I don't forget. Just find your name, initial next to it, down the column that has the date. And then make sure after you're done at your table, you pass it around, okay? I'm going to start it over here. Now, the way attendance works here is that you are allowed absences, okay? Life happens, you get sick, flat tires happen, right? You get 4 absences. That's an equivalent of 2 weeks. So after that, though, after 4, you can either be dropped or you can be given an F in the class. All right? Either one can happen. Do not stop attending class and assume I will drop you. I made that mistake when I first started college. I went to a couple of classes. I was like, I don't want, that's not interesting to me. I don't care. I stopped going. I went like 3 times maybe. And at the end of the semester, my transcript had an F. And I'm like, what? I was only there like 3 times. Why do I get an F? Well, the reason is because if you enroll in a course, it's not the instructor's job to unenroll you, right? Did I call any of you up before this semester and ask you to be in this class? No? So same policy. You get yourself in, you get yourself out. So just a little personal responsibility there, all right? If you don't want to be here, get yourself out. Mandatory lab. Okay, there it is, 800 minutes, okay? Then the two types of labs, which Rob was just talking about. All right, any questions on the difference between the two? Yes. Mm-hmm. You'll get a percentage of that. So if you do 400 minutes out of 800, you get a 50%. So, and then what is it? It's only 5% of your grade, so you would get 2.5 points instead of 5 points. So it will be based on how much you do. Now, if you go over, it's not bonus. Okay, so if you do like 3,000 minutes, you're not going to get like 20 points for it.
We need to clarify with you if we're actually, based on not having to go to the lab.
If you, yeah, I mean, I would do that because officially in the syllabus it says 800 minutes. So if you're doing well in the class but you're not going to lab, you might want to just get that cleared up with me in an email so we have it documented that I said yes. The lab is not going to affect your grade. You know, we've settled that. Okay. That'll be on you though to go ahead and reach out. All right. Electronic device policy. So you're required to silence and store out of sight all electronic devices such as phones, iPods, laptops, etc. Which is kind of funny because I'm sitting here with all this electronic crap everywhere. But for you as a student, what I expect is from 12:30 to 1:45 for you to disengage from the grid. Okay, just get off it for just a while. Let everyone know. Change your Facebook status to math class or something like that. Hour, 15 minutes, twice a week. That's what I expect. Now, if you choose to text while class is going on, the penalty is what? 10% off your next test. Very simple, laid out right here in the syllabus. So if you're sitting there behind your bags thinking, I don't see, I see. So I don't even do warnings. It's just I will make an example out of the first person. All right? And everyone in the class will see I'm not kidding around about that policy. 10 points. All right? Now, you didn't know that policy. Now you do, right? But that would have cost you 10 points. Okay? And it's nothing personal. It's just that's the way. See, I'm kind of on the fence on it, man. As a student, you're paying for class. You're paying to be here. Why should someone tell me what I can and can't do? I'm paying to be here. Well, I kind of agree with that, but at the same time, it's my job as an instructor to try and create an environment that's beneficial to all of us. And they still allow me, at least for today, the ability to make my own classroom rules. And that is my rule. So if you don't like that rule, I'm sure there's other 0302 classes that meet at 12:30. You're free to go to the math department now and try and transfer in there. Everyone think they can handle that rule? Now, I understand, again, your friend's going to have a baby today, whatever. You let me know ahead of time, hey, look, I'm expecting an important text. All I ask is that you don't text in class, you don't answer your phone, just take it outside. If it's that important, just walk out for a little bit, all right? I have a similar policy on sleeping and being disruptive. Sleeping more than being disruptive. I don't really have people that are disruptive in class, but if that happens or you are asleep in the middle of class, usually I'll just kind of, hey, wake up. But if it becomes habitual, 10% off your next exam. Again, go sleep outside in the hallway, and it's better to take an absence than to take 10 points off your next test. Scholastic dishonesty, that's just cheating. Okay, so everything is the same to me. If it's a quiz and I say you're to work alone, then I expect that. If it's a test, doesn't matter. Final exam, they're all the same to me. If you're cheating, the consequences are left to me. And those consequences can include being given a failing grade. So if you're just taking a quiz, it's worth like 1 point out of your total class grade, and you're sitting there cheating, you can get an F in the class. It's not worth it. All right? All right, tutoring. They already talked about the tutoring lab. 6 drop rule. I'm not going to get into that. That really has to do when you're taking college level courses. In Texas, you can only drop 6 classes total, even when you transfer to other public institutions. 6 total. After you drop 6 classes, you have to pay out-of-state tuition, which is not a good thing for you. So that's just kind of remind you not to be dropping, registering for all these classes and dropping, because you have a maximum of what you can do. And that's 6 total, not per semester, 6 total, lifetime, career. SOBI. Any questions? All right. SOBI. This is always an interesting thing here, SOBI. Strategies of behavioral intervention. And to me, when I look at all that, it's got all those websites everywhere, I just like, what the hell is this, I have to put this in my syllabus. I've read a little bit about it, but let me summarize the 40 pages of documents that this really entails. If you see someone acting weird, right? Nowadays, you hear someone in the bathroom talking about how to blow this frickin' place up or something. You start hearing weird shit like that, or you see someone's got a big old trench coat and, looks like he's got baseball bats hanging out of his trench coat. You might want to let somebody know, right, that you saw something kind of weird. People are acting kind of strange. You don't want to be on the news like, all the signs were there. You want to be the one who, maybe did something about it. So, I make it a habit of always watching, what people bring into class and what's, how big their bags are and what they could possibly be carrying with them. I mean, it's just a natural thing for me. And so with that in mind, I think the most important thing for us, not only to pay attention to each other, but to know what to do if something were to come up, right? We start hearing active shooter in the hallways. You know, what are our options? So since I was in this classroom at 9:30, I already know what our options are, okay? That window right there, there's a drop. I know we're on the 3rd floor, so it seems like there's no way out, but there's an awning. There's an awning, right, that goes like that. And it's about a 12-foot drop, but it's survivable for sure. I mean, it's better to maybe bust your leg up, right? This window's no-go, okay? This is 3 stories straight down, all right? That window's okay. So if it ever came to that point, right? Is that me? Okay, I have a new phone, and I have it on silent, so I don't know why it's doing that, all right? Anyone have a Galaxy S4? Shouldn't silent mean like everything's off? Let me see. Mute. Doesn't make sense. Okay, I'll get it worked out. That was just a reminder. So our options are that door obviously is one way out, and then there's exits down there, there's an exit there, and there's an exit there when we go out. So you can pretty much go any way and find an exit. And then this is like our last ditch place to go, right? So we could pretty easily throw a table. I think there's enough people in here, and if your life was on the line, I think we could get a table through that window, and we'd be out, right? That front table is going to hold the door for us. Just flip your tables up and no, okay, whatever it takes. So, has anyone heard that that saying, "Luck is opportunity meets preparation," or "preparation meets opportunity"? Something like that. I'm probably butchering it, but you know, in the event that something happened, if you're prepared, you know, and the opportunity presents itself, then it's better than not knowing what to do. I'll give you an example. I don't know how many people, most guys do this. How many guys were taught by maybe their dads or uncles or something that when you go to a public like restaurant or something, to always face the door and to always know 3 ways out? And even some women have been taught that too. Yeah. So I mean, it's not like you're living your life like all paranoid, but it's like, you know, I'm sitting at Jim's the other day, and I always sit where I can see things. I know where the exits are. I mean, there was one place that I went to. I couldn't believe there was no exit. I mean, there was just the entry, and I think the exit you had to go through like the kitchen or something. I'm like, ugh. So anyway, just pay attention to your surroundings. These days, you have to. And especially since you can't carry conceal on public campuses, which is a whole nother debate we're not going to get into. But you're not supposed to be able to carry concealed on a university or college campus, right? Same with like church. So, those are, in my opinion, the targets of people who are crazy. They go to places where they know people can't carry guns. All right. We're not going to get political. It's not a government class. We're going to keep it math related. But all right, here's our schedule. We have today the whole semester is laid out on the syllabus. Okay. Now this is tentative, meaning it can always change. We can fall behind. We can get ahead. I can change dates. But this is what I'm shooting for. We're going to do orientation today, which is me talking. We're going to review, not really, but we're going to start 2.2, and we'll get a little chance to get into 2.2 today. And then we're going to jump from 2.2 to 5.1, and I don't make up these calendars. The department agrees to a calendar. I wasn't on the committee that made this calendar, but I follow it. We're all over this book, okay? Start in 2, go to 5, then to 3, then a review, then an exam. Then we go back to 5, then we go to 7, then a review, then an exam. Then you get spring break. You forget everything, including your name sometimes. And then you come back, we do chapter 6, then an exam, then chapter 7, and then we have our review for our last exam, and then our final. So we take an exam on a Tuesday. The next day is Thursday. We review for the final, and then on that Tuesday, you don't have class. This is finals week. You don't have class on Tuesday, but on Thursday you have the final, 12:30 to 3:15. All right? Questions? Everything else on the syllabus is put in there. I cannot take it out. It's put in there by the college and by the district, so I won't read through that. You feel free to print this syllabus out if you'd like. It's probably going to be 18 pages or something like that, or just know where to go if you need to look at it. Questions on the syllabus? Questions on anything else? Yes?
My name wasn't on this.
Okay, yeah, did you put it on here? Okay, I guess everyone else? Okay. All right, for now, this is just what we'll go off. We'll probably just leave it like that for the rest of the semester. All right. No questions? Comments? Concerns? Yes? It might be required, yes. That might be the final exam, is to see who can get out of here the quickest. What's that? You might want to wait for like 3 or 4 people to go first so you can soft landing. You got to think ahead, you know. Okay, now I'm going to take a little time to talk a little bit about myself, which I don't like to do, but I think I usually don't tell people the story of like why I'm here. And every time I've done it, it's always been too late in the semester, and people are like, man, it might have helped to know that before, you know, like. So I'm going to just start this semester. I'm going to tell all my classes the same thing, the same little story, a little bit about myself. I was going to have, like, go around the class and ask about you. I just asked that if you want me to know about your situation, your life, like what's going on, if you want to have that relationship with me where I know a little more than just a person sitting here, then just come by and talk with me in my office. I mean, I had a student a while back who I think she had lost her 3-year-old daughter and was murdered or something like that. And like she showed up to the final all upset, and I'm like, what's going on? She told me, oh, my daughter was murdered like 3 weeks ago. I'm like, what the hell are you doing here? You know, like I didn't know anything, you know. So communication, like life happens, right? So if anything's going on, you just have to communicate that to me and to your instructors, because we don't know anything, right? We come here, hour 15 minutes, bye, hour 15 minutes, bye. So just, you know, be open with me, and I'll be as understanding as possible. So a little bit of background. Most people think that college math instructor is going to, you know, just be like this person who's just always loved math, you know, just love math. But that's not necessarily the case with me. So in grade school, I hated math. I mean, as much as you can hate math, I think I hated it. It just didn't interest me. I didn't care about it. And not only that, they put us in groups. I don't know if any of you were, I don't think they do it as much now because it's like everyone's a winner now. But when I was in school, it was like A group, B group, C group. And A was like, you were the shit. And then C was like, hey, you're just coming along for the ride, you know, see what you can do. So I was C group math like the whole time. I got to high school because I went to a school where it was elementary and middle school both did the same thing, A, B, C. Got to high school, same thing, didn't care. And then I had this grandiose idea that I would go to college and become a mechanical engineer. You know, I hated math. I sucked at math. My grades in math sucked. But I'm going to be a mechanical engineer. So I was like, well, I was lying to myself at a very early stage. Like, you know, I want to be an astronaut, you know, but I can't fly. You know, it just didn't make any sense. So I go to college, and I start working on the requirements for a mechanical engineering degree. Most mechanical engineers should go into college with calculus. That's what they should start with. I was like college algebra, you know, like barely got into college algebra. And it was just, you know, I was just having fun. I was young. I was partying. I was just enjoying life, right? I mean, it's part of what we do, right, as young people. And so I didn't really have a focus, and so I got eventually put on academic probation. Does anyone know what academic probation is? Okay, academic probation. Some of you might know it too well. So I was there too. So I was put on probation. So that's where they just kind of tell you, hey, look, you better get your grades up or else there's going to be some consequences. So next semester, same thing, all crap. So got put on academic dismissal. Is that the next stage? Dismissal, which I had to sit out for a semester. And that meant I couldn't go to school for a semester. So I came back, and you'd think I would have woke up by then, right? No. Same thing. So I got academic dismissal for a year. Okay, full year. Now, I've met a lot of people who've been dismissed, but I don't think I've met a lot of people who've been dismissed for a year. That means where it's like 1 year, you're done, you know? And if you want to come back, you've got to go through this whole slew of things like, you know, letters of recommendation, interviews, blah, 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 blah. So I was just like, all right. I sat out a year. In that year, I was in San Antonio, and I took a couple of classes out at Palo Alto, took a couple at SAC, just to kind of keep myself afloat. And then after the year was up, I kind of had to make a decision. I'm either going to do college or I'm going to not do college. You know, I mean, not college is not a bad road. It's just a different road, right? So I said, all right, I'm going to go for college, but I got to get it together here. So what happened was that I made a decision to care, to actually put in the effort that was required. I didn't care what it was. I was going to do it because I had to prove it to myself. So I go to try to get back in, and I had to meet with I had to talk with the dean. I had to get approval from the dean of some college, like one of the big wigs in one of the departments. And I talked to him on the phone. I had sent a couple of emails, and he was pretty much telling me, no go. Like, you're not getting back in. You've had too many chances, and you've wasted them all. So I said, just please meet with me. You know, let's just sit down, hear me out. And I had this big old like letter prepared. I was real nervous. I went to his office, and he's like, come in. He like got a phone call. He didn't give a crap that I was there. He was just sitting there. He's on the phone. I'm just all, and I look on his desk, and on his desk is a picture of a girl I'd never seen, and one of my best friends growing up, right? My friend Vince. And so I go, and he gets off the phone. He's like, all right, so what's the story? I said, well, you know, I go, you know Vince? And he's like, you know Vince? I'm like, yeah. I was like, this is either going to be good for me or bad for me. I didn't know yet. He's like, yeah, it's my daughter's husband. And then we go in for like 30 minutes talking about Vince and I and growing up and playing basketball together and all this stuff and blah, 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 blah. And at the end, he's like, hey, I got a meeting. Where's that paper? All right, signed it. I was in. That was it. And we didn't even talk about me. It was just freak kind of chance that it happened that way. So I, in some ways, got lucky with that to even get back into school. So I did, and at that point, I kind of nibbled my way enough that my basics were out of the way, but they were all like C's, and I mean, it was just terrible. So I had to make a decision. What am I going to do? Like, mechanical engineering is like a dream, right? It's not going to happen. So I said, forget all that. Instead of thinking about what I want to do and what I want to be, I chose the hardest thing I could think of. So to me, what was the thing I hated the most? What was the thing that everyone said sucked and was hard? Math, right? I mean, that was the thing. So I said, that's what I'm going for. I'm going to go for a math degree. So from that point forward, it was a completely different person. I dedicated myself to it. I spent, many nights falling asleep on the floor with my pencil in my hand and, empty bottle of wine or beer or whatever it was. I mean, I was focused on math, lived it, ate it, everything was math. And I went and finished from that point forward. I never got anything other than an A. And I finished my undergraduate degree, went straight to grad school, finished in a year and a half. And then after that, got offered a job to tutor. And the next thing you know, I'm like, okay, teach. And then, hey, do you want to be full-time? Yeah, okay. And then next thing you know, I've got tenure. And I'm like, I guess this is what I'm doing for the rest of my life. So that's kind of where, like, I'm here. But I enjoy it because I see an opportunity to try and help people get to where they want to be. I know not everyone here wants to be a math major. For a lot of you, math is just an obstacle that you have to overcome to do whatever it is that you need to do, nursing or, business or whatever, right? But you can't walk in here and not care about math. You got to care about yourself enough to want to do this right, and you got to put in the effort. If you're willing to do that, I will meet you more than halfway. But if you're where I was in the very beginning and you don't know what you want to do, and it's just kind of you're just floating around in the abyss like I was, then my advice to you is just not do it. Don't waste your time, don't waste your money, and don't screw up your GPA. Okay, if you're not focused on your education, then it's really not worth it. Because I don't think I ever recovered my GPA. I mean, no matter what I did, I could not get my GPA up. It was just devastating what I did in the beginning. So that's a little bit about me. So I'm not some math dork that's been a math dork my whole life. Now I'm a math dork, all right? But I can associate with people pretty well, all right? All right, well, I hope that in some way gives you some idea of what's going on here up in front of you. I'm ready to start. So I thought I would start today with one of my favorite examples, because this is a little humbling to most people, as it was to me when I first saw it. Do you remember order? I'll give you a second to get stuff out if you want to write. Order of operations. Y'all remember that? Oh, do what? I don't think I have any pen, but I'm sure that someone around here does. Okay, order of operations. What are the order of operations? You've probably heard it before, the PEMDAS or something like that. PEMDAS. I learned it, please excuse my dear Aunt Sally. Did anyone else learn it that way? Please excuse my dear Aunt Sally. And what the order of operations are is just a kind of a cute way of remembering the order in which you're supposed to do things in math, right? You're always supposed to do parentheses first, then exponents, multiplication, division, addition, subtraction. That's what those stand for, right? So let's just see how well we learn this, and let's see how well we were taught this, right? Because there's a difference between not knowing something because you don't remember it and not knowing something because you were shown the wrong way, all right? So let's try this. And we're going to use the old school notation. When I say old school, I'm talking like grade school notation. That's division, right? Multiplication. At some point, we stopped using those. Especially the multiplication, we stopped using that because that's kind of confusing whenever you start getting x's in there, right? All right, so go ahead. You tell me what that is. I'll take a vote. We'll see what the answer is. We'll take a poll. Everyone ready? Okay. So the two answers that I normally get in this problem are 1 or 16. All right, those are the two. I usually don't get anything other than that. So if you got something other than 1 or 16, we need to talk. Let's do a show of hands. And no one, don't be embarrassed, okay? You can't be worse than being kicked out of school for a year, all right? So I'm the one who's probably the most embarrassed. How many of you got 1? Okay, look around. 1, all right? 16? Okay, that's about, it's a little, about half. The correct answer is 16. My other class at 9:30, only one person got the correct answer. Everyone else got 1. So the correct answer is 16. So the reason I show this isn't to try and humiliate people. It's to try and remind you that even though you may feel very confident in what you're doing, there are things that still there might be holes in. So if I'm covering something today or tomorrow or next week where you're like, I got this, I got it, then you still need to pay attention because there might be something that you didn't know the way you should have known it. Okay, so here's the problem. Most people are taught multiplication before division to mean multiplication before division because that's the way they were taught. But that's not correct. What is the correct way? For those who, whichever one comes first, left to right. Correct. So if you look at a problem, multiplication and division are not in that order, multiplication then division. It's, if you see multiplication division, you read it like a book from left to right. So you actually do the division before the multiplication here. That's the rule. So one of two things has happened for those who got 1. Either you don't recall it correctly or it was taught incorrectly. One of the two, right? For me, when I was growing up, it was taught incorrectly, I think, because that's the way I remembered it. So maybe I just didn't remember it right. But Addition and subtraction are the same thing. It's always left to right. But addition and subtraction, it's not, it doesn't mess things up as much as the multiplication division can. So what we would do here is we would say if this is equal to, we would do the 12 divided by 3 first. 12 divided by 3 is 4. 4 times 4 is then 16, right? So, okay. I hope I've made my point. I was just trying to illustrate, you know, got to be careful with what you think you know. All right. Today, I'm going to start, and we only have about 20, 25 minutes. I'm going to start the section 2.2, which is called linear equations. Now, I mentioned earlier that I teach another class. I think I'm going to go on this side for a little while. I've been on that side way too long. I teach another class at 9:30, right? So if at any day that you can't make this class, but you know you kind of know that ahead of time, and you can make my earlier one, you're welcome to go and sit in on that one. I told them the same thing here. If they miss, they can come and sit in. But keep in mind, all this is recorded, so you should just be able to watch everything you miss. But you still have to be here, okay? Still take attendance. It's just, you know, this is all for you to go back and look at if you need to. Linear equations. So what is a linear equation? To start off, I mean, we got to know what we're looking at here, right? Equation means that we should see an equal sign somewhere, right? And then linear means that we're going to have a variable in there, and that variable, the power on it is a 1. That's what linear means. So let me give you an example. 3x minus 5 equals negative, I'll make the numbers work out okay, negative 9. Okay, this is a linear equation. You have the equal sign, you have the variable, and what's the power on that x? It's a 1. If it's not written, it's a 1. Now, later on, you may deal with problems where there would be a squared up there on that x. It's no longer a linear equation. It's then called a quadratic equation. If it changes to a 3 up there, then it's a cubic equation. 4, then we start calling them 4th degree equations, and then 5, 5th degree. Any of you who take college algebra, you'll deal with quadratic, cubic, 4th degree, 5th degree, 6th degree. But here, we're just making sure we understand how to handle 1st degree, which is linear. All right, so how do we attack this? So let me ask anyone, how would you solve this? How would you solve this linear equation? You're adding 5, is that what you said? Add 5 both sides? And then, okay, why not divide by 3? Because there's a 3 in front of the x, so why not divide by 3? Yeah, but if I divide x, the 3x by 3, won't it just cancel and I'll just have an x then? Okay, so if I divide 3, can I divide everything by 3 then? And it would still be okay? Okay, so I'm asking these questions because a lot of you kind of know how you do this. All right, I'm challenging you to to kind of explain why it is you do that, right? The correct step is, yes, add 5, then divide by 3. You don't divide by 3, then add 5. There's an order. So what I'd like to do is, if you're comfortable with this and you have a way of doing it, it's fine. But bear with me and let me write down some steps. A lot of people like steps, right? Give me a process that works for all linear equations. And that's what I'll provide right now. A 6-step process for solving all linear equations. If you follow these steps, you should have no problems with linear equations. Well, you might run into little problems like, you know, what's this plus this, or what's this minus this, but as far as the steps, you'll have something to go off of. So to the side, let me list the steps to solve. The first step is remove grouping symbols. And What I mean by grouping symbols is parentheses, brackets, and braces. So I'll just put on here parentheses, brackets, and then the braces. Now for us in this problem, do we even have grouping symbols? Not in this problem. So we're not going to have to do a step 1. But that's what we would always pay attention to first. The second step would be to clear fractions and or decimals. Because we don't like working with fractions. My handwriting will get better. I haven't been writing for about a month, so I'm getting back into it here. We'll clear fractions and or decimals. So we don't like fractions, so if we ever see them, what we'll do is we'll multiply both sides by an LCD, and we'll get into it when we have an example like that. But we want to get rid of any fractions and any decimals. Anyone remember how you can move a decimal point? Like, how do you get something that's a decimal, move it to the right once? What do you multiply by? 10, right? If you want to move it twice, you multiply by 100. But again, we'll see that when we get to one of those problems. All right, after we clear the fractions, we will collect like terms. And we'll, again, talk about what's a like term once we get to some examples. But that step is saying, look, if you've got like numbers like 3 and 7, you know, add them together, turn it into a 10. Or if you've got a 5x minus a 2x, put them together, make it a 3x. Collect all your like stuff together. Then the step 4 is a critical one. This is isolate the variable term. The variable term. So in the problem that we were working on right now, the variable term is the 3x. And we would want to get it isolated, which means, what does isolate mean? Get it by itself. And that means on one side of the equation by itself, just that. And so we will have the freedom of choosing the left or the right. It'll be up to us. The last, oh, wait, not the last, second to last, solve for the variable. Is my handwriting legible? Is it okay? Solve for the variable. And then the sixth step is to check your answer. We always want to make sure that the answer we got is right. So that's the process, all right? You do that on linear equations, you should be in business. Now the one that we just did, I'll go back up to. I'll write the step down real quick. Step 1, remove grouping symbols. That's done, right? Don't have to worry about it. Step 2, clear fractions. Do we have to worry about that? No, check. 3, collect like terms. So I'm going to look on the left side. Can you put 3x and -5 together? No, because they're not like terms, right? It's like a dog and a cat. You can't put them together. I mean, I guess you could, but you know what I'm saying? Like you wouldn't expect to leave a cat and a dog together for a while and expect babies, right? I mean, they just don't go together. So 3x and -5, they just don't work out. So leave it. How about on the other side? -9 all by itself, nothing to do. So this step's also done, right? All right, step 3. Step 4, isolate the variable. So this is actually the first real work we have to do on this problem, is isolating the variable. So step 4, I will need to do something. So I'm going to go ahead and write this down again. 3x minus 5. I'm just bringing it down so I don't have to scroll back up and look at it. Now, everyone told me that to get the 3x by itself, I needed to add 5, right? So to add 5, there are 2 ways to do it. It's called vertical addition or horizontal addition. And most of you have done it this way. Add 5, do you agree? You would do it like this, plus 5 here, plus 5 here, right? Does anybody do it the horizontal way? Horizontal looks like this. 3x minus 5, but then I do plus 5 here, and then equals the negative 9, and I do plus 5 here. So I keep it all on one line instead of introducing a new line below. Everyone's good with the vertical? This is vertical. The book does horizontal, just so you know. So if you look at the book, an example, they do horizontal. It's the same as this. They just write it all that way. The reason they do that is really down the road, sometimes it keeps track of everything a little better, but most people don't do it. All right. So now, how many of you that do it this way put a line and then actually come down? Anyone put a line? Okay, it's weird. It's so different. The other class, like everyone's like, put a line. I don't put a line. It's your call. Okay, some people do. I just want you to see some people do. You do whatever you're comfortable with. Now I'm going to add down 3x. Nothing cancels with it, so it's just 3x. Negative 5 and positive 5 cancel, right? And then on the other side, what do we have? Negative 4, right? And what am I missing? Equals. Don't forget that equal sign has to come down, right? I've seen students, this is a big critical step. They don't bring the equal sign down, and all of a sudden you don't have an equation anymore, and then they're just like, they get lost because like the equal's gone. So they start going weird places with this. Okay, so bring that equal down. Now what? We've isolated the variable term. It is isolated. So now step 5 is to solve for that. So how are we going to solve for the variable? How are we going to get the 3 that's being multiplied in front of x out of there? Divide by 3, right? Why not subtract? That's right. You do the opposite of the operation. If the operation between the x and the 3 is multiplication, to undo multiplication, we divide, right? Okay. So I will divide. So I'm going to write a new line here. I'm not worried about running out of paper. I just keep adding new page, you know, I'm good. So I'm not afraid. All right, divide by 3 on both sides. 3's cancel. That leaves me with the x. Then the equal sign. And then on the other side, negative 4/3. Let's just leave it as negative 4/3. And we are done, right? Now, we should check our answer, which means we should check it by plugging it back in, right? I'll do that. Any questions, though? I hope this is all like, okay, good, you've seen this, everyone's happy. Okay, to check it, what I'll do, to check properly, what you do is you write down the original problem. I think I'll go to a new page. You write down the original problem, which was 3x minus 5 equals negative 9, right? And you're going to replace the x with what you just got. What did we get? Negative 4/3. So I'm going to put in parentheses right here, negative 4/3. And then I have minus 5 equals negative 9. That's the way I would write it. I only put the parentheses there to represent the x. This is 3. This is the x that I just found. Now, what's going to happen there? What's that 3 times negative 4/3? What happens? Okay, you can look at this being, there's so many different ways that people are comfortable with this. I want to write a couple of them down. You could look at that as 3/1 times negative 4/3, right? Or you could just multiply across the top and just say negative 12/3, right? Or you could be like, cancel the 3's. Any of those are right. It's just which one are you most comfortable with? They all turn out to be negative 4, don't they? So the question is more of, for you to, reflect upon what you are comfortable with and go with the one that makes most sense. So the first multiplication there should turn into, this right here, should turn into a negative 4. And then what else do we have next to it? We still have minus 5 there, right? So minus 5. Does that equal negative 9? Yes, it does. So it checks. All right. So what do y'all think? I mean, this is This is kind of the way that it would be if I just did this like this. And I'm willing to do a whole day with just up on the board. If you want to kind of get a feel for both, I can do that too. But I'd like to finish off the week next class with this, all right? But so far, are you sitting there going, oh my God, how can I sit in this dark room for an hour and 15 minutes twice a week without, you can be all right, you think? Okay, all right. Okay, we need to do something a little more complicated than that, right? That was just to get ourselves thinking again. Some of us, including me, decide to kind of reformat the entire hard drive, mental hard drive every break, especially this Christmas break. It's like a full month off. It was long. Yeah. Now that's more like the kind of math that makes you sick, right? We start, it's like, oh, show me an easy example, and then all of a sudden do something like that, right? Now, one of the things that I did and continue to enjoy about math is the fact that it is very systematic. It is very process-oriented. This step, as long as you don't break a rule, it's going to work out. We should all get the same answer, right? It's not like an English paper where you write it, you think it's the best paper that's ever been written, you get it back, it's a D, You know what I'm saying? That happened to me a lot. I didn't like that at all. So let's follow the steps. First step would be remove grouping symbols. Now there's a lot of grouping symbols here. We have a set of brackets on the outside here. Inside that we have parentheses. And then on the other side, we got another set of parentheses. So we got lots of grouping symbols there. The rule with grouping symbols is to actually start on the inside and work your way out. So I'm going to go inside the brackets, the yellow, to that kind of pinkish. And I'm going to try and remove the parentheses around the x minus 4. So how can I remove the parentheses around the x minus 4? I'm going to look at that 2 in front. I'm actually going to look at it as a negative 2, and then I'm going to distribute it through. And distribution means multiplication, right? For both. So the negative 2, I didn't like that one. The negative 2 will come and multiply times the x, and the negative 2 will multiply times the negative 4. Everything else in the problem remains the same. So here I go. Negative 5. Ooh. Bracket 3. Now, the negative 2 passed through the parentheses and became, first of all, a what? Negative 2x, good. Plus 8. Plus 8, because a negative times a negative is positive, right? And then what about the x out there at the back? Just leave it, right? That negative 2 did not go and hit that x. So I still have a plus x back here. Okay, now within the brackets, we can combine like terms. But let me keep writing the rest of this thing out so I have one line. Equals, would you like to try and get those blue parentheses to go away? We can do it now in this step if you want. Yeah? So we'll pass the negative 4 through the parentheses, same way, right? Multiplication. So negative 4x, that's negative 4 times x, and then negative 4 times positive 1 minus 4. All right, so we were able in one line to remove 2 of the sets of parentheses. I do like the idea of looking inside this bracket here. And before I pass the negative 5 through this, okay, that's what I'm going to do. Before I do that, I like the idea of putting everything in yellow there together first, like collecting like terms. So I've got a, what do I have in there that I can put together? The 8 and 3 can go together, and then the negative 2x and the x. So rewriting everything, again, I'm not afraid of using too much paper. Should I put the number first or the variable? It really doesn't matter. It's not like it's wrong one way or the other. and there's really no convention for it, so you just do whatever you want to do. What would you like? Number first? Letter? Number? Okay. 11, right? And then what's negative 2x plus x? Negative 1x or negative x? Or minus x? Look, if at any point in time I ever do something and you're like, you want to be all shy about it and not ask, you're like, oh, I'm going to look like an idiot if I raise my hand, at least just put a star or something next to it so that you can go back and ask me later. Don't be like, hey, there was something you did in class I didn't understand, but I can't find it. Like, at least make a note for yourself so I can help you, all right? All right, now what? We're still step one. We're still trying to remove grouping symbols. Distribute again. Okay, negative 5 is going to go through. It's going to multiply here and here. So we treat brackets just like parentheses, don't we? All right, we get negative 55. We get plus 5x, negative and negative is positive, equals negative 4x minus 4. All right, we have removed grouping symbols, haven't we? Next step would be to clear fractions in decimals, right? That's step 2. We don't have step 2, so next to here, step 2, I'm good. Step 3 in the process was collect like terms. So on the left side, can you put the negative 55 and the 5x together? No. On the right side, can you put negative 4x and negative 4 together? No. All right, so we're done with step 3. Isolating the variable term is the next step. And now we have a little bit of an issue because we have the variable on both sides, right? So you get to choose now which side you want your final variable term to reside, either on the left or the right. Again, there's not one way is right and the other way is wrong, but there is a smarter choice because we want to try and keep our variable positive. Right now we have 5x. If we were to try and remove it from the left side, we have to subtract 5x, which would make this a negative 9x. Whereas if we tried to get rid of the negative 4x on the right, we would add 4x, and it would become a 9x on the left. Does that make sense? So I'm going to deal with the variable first. I'm going to write down, I'm going to choose vertically to add 4x to both sides. What about the numbers? If I'm going to do this, my x's are going to wind up on the left, right? That means my numbers need to wind up on the right, which means I'm going to need to get rid of a negative 55. How do I get rid of a negative 55? I'd add 55, right? Both sides. I'll do that simultaneously, right? No one uses the line, so I don't know why I'm using the line. But, oh well. I'm trying something new today. Okay, so let's add straight down. We get nothing here. 55's cancel. How many x's? 9x. Equals, don't forget that. The x's on the right cancel. What is negative 4 plus 55? 51. Questions? Now? Divide both sides by 9. So I take my 9x, divide by 9, take my 51, divide by 9. 9's go away. X is 51/9. Now, every problem that I do in this class, your answer will be an improper fraction. You will never be asked to convert it to a mixed number, right? There's a reason why. Let me take something like decimals, yes, but not as, like you would never take like 5/12 and turn that into, what is that, 2 2/5, right? Those are the same thing, right? There's a reason why. 2 2/5, mixed numbers are kind of like I was saying earlier, the division symbol, like that's the old school division symbol. Like this is like old school, the way you write fractions. This is what you're taught in elementary school. But as you go higher and further into math, you don't even mess with mixed numbers anymore. You always leave them as improper fractions. And the reason I think it's that way is because most people don't even know what this is. Like, is this 2 times 2/5? What does this mean? It actually means 2 plus 2/5. So why isn't there a plus sign there? So it's just confusing, I think. And that's why I don't like mixed numbers. So you just leave it alone. Now, I wouldn't take off on the test if you put a mixed number, but I will never ask you to put it to a mixed number. Okay, tonight, we're out of time. Perfect timing today. No homework except to have the book for your homework assignment next class. Yes? Yeah, you would reduce them, though, yes, if you could. This one, does it reduce? Oh, yeah, it does. Didn't notice that right away. Yes, 17th. Now, again, you wouldn't be taking off, you know, I mean, it's the same number. I'm not real big on that sort of thing, so. Yeah. All right, everyone have a good day. See you on Thursday. Okay.